Hello, my name is Jan Martin. I'm a technical translator, editor, and linguistic consultant. And this is a little instructional video for demonstration purposes, in which I'm going to show you how to design and 3D print an object such as this. This video has subtitles in German. You may have to activate them by clicking the subtitle icon below this video. Now, this object here that we want to design is a keyring with a logo on it, which has two helpful little functionalities. For one, it has a bottle cap opener, so you can open bottles with bottle caps, such as Coca-Cola bottles or beer bottles, if you're so inclined. And it also has this slot here, which is a slot for trolley tokens or shopping cart coins. So you always have one handy if you need a shopping cart, because you don't always have a euro coin. All right. First, we're going to design this, and then it's going to be 3D printed. Before we design the actual object, we will need a reference for the size, which is the size of the bottle cap. It has to be the right size. So what we're going to do is create a sketch, which is a 2D drawing, which can be converted into a 3D object at a later point. But first, what we're going to do is just create a reference drawing for a bottle cap. Bottle caps are approximately 29 millimeters in diameter and about 5 millimeters high. So they look kind of like this. I marked this as a construction drawing, so it doesn't influence the actual sketch profiles. Now we need to insert the logo that we're going to use, which I have already prepared as a scalable vector graphics file. Yes, this is best done in a graphical program such as GIMP or Photoshop. They're pretty much all alike in this respect. You need to export the scalable vector graphic, and since we already done this, we insert them by using the insert SVG command. Selecting the file. And inserting it so in a size that makes sense. So if you want to open this bottle cap here, it would have to be a bit smaller. A bit smaller still. Yes, that should be about it. Now we have the logo to create the body of the keyring, this white part here. We're just going to offset the logo line by 3 millimeters. And already we have a good sketch profile for creating the body. A sketch profile is a closed line that can be converted into a 3D object later on. What we don't want is these sharp points here. We don't want to hurt ourselves if we put it in our pocket. So we'll insert a circle with a diameter of 6 millimeters. I'm going to use the trim tool in order to snip away these parts we don't want. Now next we need an eyelet, a hole to attach the keys. We're going to put it about here, and we start by creating a circle 12 millimeters diameter for the outer part of the plastic shell and an inner diameter of 6 millimeters for the hole. Now we attach these two circles to the main body with lines like this. They don't have to be exact because we will constrain them as tangential to the circle, and then also add a parallel constraint so they will be parallel and visually pleasing. Now this is a bit too big actually, so we're going to move those circles a bit closer, and yes, this is a good place to have this eyelet. And again, we trim away all the parts we don't need anymore. The final feature of this sketch will be a little cutout to engage with the bottle cap. We're going to use the line tool to cut out a little bit here and snip away the line. All right. We now have the final profile that we're going to extrude into a 3D object. So we finish the sketch and choose the extrude command. Select these two sketch profiles and enter a height of 5 millimeters because that's the height we want to have for the body of our keyring. Now we want to put the logo on top, so need to select the logo and extrude it as well with a height of 6 millimeters. Now, if we extrude something into an already existing object, it's going to cut it out by default as indicated here. So we have to make sure to select join instead of cut. All right. Next, we'll give these edges here a fillet, which means they will be rounded. This is done by the fillet tool. Now we need to select all the edges. Except for this one, which we don't need, and enter a radius of 2. For the inner edges of the eyelet, I will choose a smaller fillet, just one, because we don't have space for any more. Right, so we're almost done. As a final step, we're going to make the slot for the trolley token. Now, I already created a keyring like that. and created a tool body for making these cutouts. A tool body is a body that you use to combine with another object to make a cutout or to add something. It's called Einschub in this example, and we're going to copy it and paste it into this file like so. Turn it around. Position it just as needed. All right. And now keep in mind that these two objects are not combined. They are not one object, they just overlap. So I could disable this one, and they still exist as separate objects. But now I'm going to combine them. This is the target object, and as a tool object, or body rather, this is selected. All right, so now we're already done, almost. What we still need to do is improve this thing here, because this is going to be made out of plastic, and it will wear down with the stress of opening all these bottles. So we need to put something here that's a little bit beefier, a little bit more plastic. So we're going to create another sketch, actually, very simple sketch. On top of this one, we're going to create a round line with the 3-point arc command. Like this, 2 lines like this, and this is already the sketch we need. We'll extrude it like before, making sure to select join. And now we have a much tougher tooth here for engaging with the bottle cap. Now we can also apply an appearance to this body in order to make it look nicer. This is irrelevant for the 3D printing process, but it just looks so nice. Make this white and then select faces so that the green will only select the top surface here. And now we already have the final keyring that we're going to print. So now that we're done designing, we can get to the technical part of this video, which is going to consist of converting our design into a real-world object made out of plastic. To this end, we're going to use FFF 3D printing. FFF means fused filament fabrication, which means that hot plastic is going to be squeezed out of a nozzle onto a print surface in pathways and layers, which I'm going to demonstrate right now. We can't just directly give this 3D model to a 3D printer. Rather, we have to convert it into a set of instructions, mostly for movements, but also parameters such as heat. And yes, we need to create a file containing these instructions. Now this is the 3D printing utility. And with the standard settings, we can already see how the process is going to work generally. What's going to happen here is that a nozzle is going to squirt the hot plastic onto the print surface. First, it's going to create 2 outer perimeters and then fill the interior with infill. Now this is external infill, solid infill, which is used to create the outside of the object. And as we are going to get inside, there's going to be interior infill. Most of the part is going to be hollow, but there are going to be these struts connecting the perimeters, so we can have more stability. Now the perimeters themselves are only 0.4 millimeters wide each, so 0.8 millimeters in total, which is not a lot. The walls of this object are going to be rather thin, which is a problem because I'm afraid that the bottle cap is going to put too much strain onto this tooth here, and it's going to be worn down rather quick. And furthermore, we'll get to a point where we are printing in thin air, right here. You see here that the outer perimeters are going to be created, and then it's going to print here, and all this plastic is going to fall down on the print surface, and it's not going to work at all. So we have to find a solution here for these two problems, and that's going to be done by creating proper settings on the basis of our standard settings that we have loaded here. So first off, we're going to increase the width, the extrusion width, which means the width of all the pathways, including the perimeters, a bit. So we have 0.5 millimeter here. And we'll also increase the count of the outline or perimeter shells to 3. So that's 3 times 0.5, 1.5 millimeters, which is already much better than the 0.8 millimeters we had before. Furthermore, we're going to create support material in order to be able to print in thin air. We need to make sure that we're not creating support material everywhere, because as you can see here, we have these cavities as well where there's nothing, and then there's going to be plastic on top, and we don't want any support material here because that would interfere with the spring mechanism. And this little part here is so small that we're not going to need any support material. You can print a little bit over thin air for these small sections. So we're going to tell the application only to build support material on the print surface and not inside of the part like this. Choose a nice wide offset so we can easily remove the support material afterwards. And we're done. Now you can see that there is a lot of gray stuff here, which is the support structure. And now we see that the plastic is going to be laid down here on the support structure, so it's not going to fall down. And also we have a much thicker outer walls consisting of 3 perimeters. that is going to handle the stress from the bottle caps just nice. So we're done here, almost, but we can already save the file. Let's save it. We have to take care of one thing, because we want to have two colors, right? We want this in white and then the logo in green. So we will need to change the plastic that we're going to be printing with. In order to do this, we need to insert a pause command into the G-code file that we just created, and we need to look just where to put it. Now you can see here the number of layers. If we print the complete object, it's going to be 30 layers. And we need to figure out where is the last layer of just white and where does the green part begin. And it turns out that 25 is the last white layer, and then the green begins. 26 is already green. And search for the layer that we want. Layer 26. So we're going to put the pause command M600 right before the layer 26. And now we're ready to print this file. Right, so by now the file is printed, but I'm not going to bother you with the details because this video has been going on for long enough. And also the details are going to depend on the printer you use. Just let me say that it turned out all right, and this is the result. And you can see I can insert this token like this. Goes in with a nice click. And well, I hope you learned something today, found this informative and entertaining. And yes, a good day to you. Bye bye.